So now I want to talk a little bit more about these upper level patterns because looking at the upper levels, as I've mentioned before, is really going to help you in your forecasting journey. And it's something that I want you to understand and know how to identify, especially when it comes to your final forecasting project. And so here, this is the common upper level signatures 72, 48, and even 24 hours out before a nor'easter impacts the Northeast. And so what we notice here is that we have an interaction between two jet streams. So in the wintertime, we have the polar jet stream and we have the southern jet stream, or is also known as the subtropical jet. And so there's usually a merger between these two. And to make it a little bit more gen ed friendly, I'm not going to go into too much detail about it, but I want you to understand the patterns, and I'm going to highlight the different patterns for you. So here we have the polar jet stream, we have the subtropical jet, and there's usually some kind of cut off trough or cut off low that spins in southern Canada or just north of the Great Lakes. And this usually is a piece of the polar vortex, typically. So looking at an example here in an artisan drawing, we've seen this image before. So here would be the overall jet stream. Here's the trough axis. If we cut the trough in half, our area of low pressure is on the right. Our area of high pressure is on the left. And so our area of high pressure is associated with cooler air or colder air moving in or moving south from the north. And then it's just the opposite for the warm front moving from the south to the north. So that is the vertical structure of what our atmosphere looks like, and we've talked about it in different videos. But here what I want to do is I want to show you what the upper level looks like with different areas or different versions of nor'easters. So here what I notice is that here's my cutoff low to the north in Canada, and here what I have is I have two jet streams. And it's a little bit harder to see, so I'm going to highlight this for you. So here is our northern jet, like so. So basically, if you take this line, this 534 millibar contour, and above, that would be the northern jet stream. Below that, here would be the southern jet stream. And so you can see there's not too much of a big trough or ridge. It's almost pretty flat, but what you notice is that the jet stream is slightly tilted, that anything that is caught in the jet stream is really just going to move into or track into the northeast. Whether it's just south of the northeast or it actually impacts the northeast is to be determined. But when meteorologists see this pattern, you notice that it's actually in a good position that we could get some kind of significant event. So that image was February 8th of 1994. That was the 12Z surface map. And here was the 9th February 1994, so this is 24 hours later. So here again we have the northern stream and the southern stream. And as far as vorticity goes, here we notice that here are the deep oranges. So this would be the area of greatest spin, basically off the Baja coast of Mexico. And so what we notice, again, 24 hours later, here's that area of vorticity moving through Texas. So here's our trough. Cut the trough in half. I know that my area of disturbance or my area of low pressure is developing in the Gulf of Mexico. Now here, this is the southern jet stream. So it's going to ride the southern jet stream, interact with the northern jet stream, here where all this cold air is back through New England, and really intensify off the East Coast like we've seen in the previous videos in this module. So now another 24 hours later, so here is February 11th at 12 Zulu. So here what you see is that here on the right hand side at upper levels, this is our southern jet stream. Here's our trough axis. Here is the area with the greatest spin. I cut the trough in half. I know that my center of low pressure is going to be just ahead of my vorticity maximum, or my area of greatest spin, or my darkest color on this map. And so here, that's exactly what you notice. Here is the area of low pressure. And so at the surface, we also notice here's the new developing low. So this would be a track B type of low. We also have an area of high pressure centered over New England. Here, and there's no color scale, but usually these blues would indicate what we call negative vorticity. This would be positive vorticity. So positive vorticity is the vorticity that spawns low pressure systems. Negative vorticity will spawn anticyclonic or high pressure circulations. So this makes complete sense that there's high pressure on this map. Here is our area of negative spin or anticyclonic spin. So here is our area of low pressure, and here you can see how this system already is going to redevelop off the east coast and then again track just along the jet stream and just track just south of the 4070 benchmark. Here's another example. Here's February 1st of 1995. So here's the 12Z surface map. Again, here, right along this line, this is the boundary between the northern jet stream and the southern jet stream. So here we have the subtropical jet. Here's our little trough. Cut the trough in half. Here's our weak area of disturbance in the Gulf of Mexico. We fast forward 12 hours later. Here, you can't really see it. It almost has disappeared, but it's still there. But here is our little weak parent low that is developing out towards the Midwest or just west of the Midwest. But here you can see here is this deep trough. And so I know that any energy systems that get caught in this trough are really going to explode and really intensify off of the East Coast. So here you can see how the East Coast is really in prime formation. So here the jet stream, anything that gets caught is going to ride this just south of southern New England. And then 24 hours later here we have a very, very deep trough. Cut the trough in half. Here's my area of strongest spin, or my parent low would be on the right side. And that's exactly what you see. You have a very strong area of low pressure developing off of the coast of New Jersey, Maryland, the Virginia area. So basically the mid-Atlantic coast, and again, riding up into New England. Here's our area of high pressure. I know that that's my cold air in place, so I know that I have a prime scenario for snowstorms. Here's another example. This is January 22nd of 2000. Here's my upper level low. But again, I have a very zonal jet stream. I don't necessarily see any troughs and ridges. This is a very, very flat jet stream. But when I fast forward 12 hours later, here we have a little bit of a trough. This would be the northern jet stream through here. Here is the southern jet stream back in through here. We fast forward 12 hours later, and what do we notice? Here, these jet streams, here is a large trough. You can think of it as two troughs. You can think about it as a trough in the northern jet stream, right in through here. Or you can think about it as another trough in the southern jet stream, in through here. Either way, you can think about it as one trough. If you get confused by the northern jet stream and the southern jet stream, don't get caught up too much in it. I'm just trying to highlight it for you. You can think about it as one giant jet stream. That is totally fine. But here, if you want to think about it that way, you have one giant trough, okay, extending all the way from the Great Lakes all the way down to the Florida Panhandle. So I know my area of low pressure is going to be on the right-hand side, and that's exactly what happens. So this would be a great example of an upper level map for that track B, that Atlantic coastal redevelopment, where we have that parent low feeding its energy to the new developing low. And so here, what do we notice is that this trough is not necessarily straightforward, it's almost tilted. See how it's almost on its side? That's a tilted trough. Whenever a trough is tilted like that, it really causes these upper level energy systems to really cause some intense spin. So when we have this intense spin, we really notice at the surface that we have a very strong area of low pressure.